So, any questions?
Teacher, what's the difference between a chord and a secant?
Man, this kid is stupid. Okay, so a chord is a segment whose endpoints are on a circle. Look very closely. This is a chord. Okay? And a secant is a line that intersects a circle in 2 points. And this is a secant. You see, Andy? And I'm sure you have more questions. So, this would be a radius. A segment whose endpoints are the center and any point on the circle. And this is a center. And this is the circle. Any questions now, Andy?
Teacher, you forgot the tangent.
Sorry, I forgot the tangent. Okay, so this is circle again. And this is the tangent. Remember, a tangent is a line in the plane of the circle that intersects the circle in exactly 1 point. And this is the point, which is the point of tangents. Remember, tangent lines are perpendicular to the radius. What's the radius? There's a right angle. Pretty good.
Teacher, I don't get it.
Wow! Hey Gary, you are the best student in this class. You come here and teach this kid. I am tired of this job.
Huh? Okay, so this is the center. This is called a minor arc. The minor arc is equal to the angle measurement of this, which is called the central arc. This measurement is called the major arc. You find the major arc by subtracting the 360 from the minor arc. Get it?
Good job, Gary. I knew you could do it. Now, Timothy, you get up and show how to do the next section for Andy. Hey, get up!
Huh?
Go up there! Show him how to do the work.
Okay, so in a circle, two minor arcs are congruent, only their corresponding chords are congruent. So these two. So in here, AB is equal to CD, and that means these two minor arcs are equal. And also in this chapter, you can tell if two chords are perpendicular bisector of each other, then the first chord is going to be the diameter of the circle. And here, AB, CD, AC are perpendicular bisector of each other. And therefore that means AB is the diameter of the circle.
Good job, Timothy. I want you to continue. Show me your hard work.
Okay, so the measure of an inscribed angle, let's see. The measure of this inscribed angle is exactly 1/2 of the arc. So measure ABC equals 1/2 the arc of BC. Also, another note, if two inscribed angles intercept the same arc, the two angles are the same. So therefore, these two triangles, these two angles, are the same measure as this arc. And also, you can tell if the triangle is 90 degrees total if this line is the diameter of the circle.
Good job, Timothy. Now that I think about it, I don't really want to lose this job. I need to raise my family of 10 kids. Now I will get back and teach you guys. So I'm teaching again. You better learn stuff, Andy. So this is theorem 10.11. If a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intersected arc. You see this angle measure 1? It is 1/2 of this measure of arc AB. Measure of angle 2 is 1/2 of arc BCA. And over here is theorem 10.2. Angles inside the circle theorem. If two chords intersect inside a circle, then the measures of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. Measure of angle 1 is 1/2 of measure of arc DC and AB combined together. Just right here. And measure of angle 2 is 1/2 of arc AD and arc BC combined together, which is right here. Okay, so let's continue. This is theorem 10.13. Angles outside the circle theorem. If a tangent and a secant, two tangents or two secants intersect outside a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. You see here, measure of angle 1 is 1/2 of arc BC minus measure of arc AC. Measure of angle 2 is 1/2 of arc PQR minus arc PR. Measure of angle 3 is 1/2 of arc XY minus arc WZ.
So sorry, I'm late.
You're late again! Your punishment is to teach this guy, Andy Chen, how to do the next section.
Chapter 10.6. When two chords intersect in the interior of a circle, each chord is divided into two segments called the segment of the chord. If two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the length of the other chord. So if EA times EB equals EC times ED. And then a second segment, a secant segment, is a segment that contains a chord of a circle and has exactly one endpoint outside the circle. The part of a secant segment that's outside the circle is called an external segment. And then a tangent segment is over here. So it says that if the external segment EA times the secant segment UB, it will equal to the tangent segment EC times the whole segment ED. Theorem 10.6. If a secant segment and a tangent segment shares an endpoint outside a circle, then the product of the lengths of the secant segment and its external segment equals the square of the length of the tangent segment. So if EA squared is equal to EC times ED.
Good job, Linda. Now, Andy, do you understand everything now?
I understand everything now.
Good job, Andy. I knew you could do it. Now, would you please show us the last section?
So this is the standard equation of a circle. This variable and this variable represents the two coordinates of the center of a circle. So if the center were the origin, this would be 0 and this would be 0. And that's the radius.
I hope you learned something from today. Your homework will be this whole book.